why workforce safety is an overlooked sustainability lever, and how AI is changing that. For years, conversations around sustainability have centered on emissions, energy efficiency, and resource optimization. These remain critical priorities. Yet across high-risk industries, one of the most powerful and often under-examined drivers of long-term sustainability performance lies closer to the ground: how organizations manage human risk. Workforce safety is frequently discussed as a compliance obligation or operational concern. Rarely is it framed as a sustainability lever. But in critical, asset-intensive environments of construction, manufacturing, energy, mining, and logistics, the link between human risk reduction and sustainable outcomes is neither abstract nor theoretical. It is structural. As artificial intelligence becomes embedded in operations, this connection is becoming more visible, measurable, and strategically relevant in 2026. Most organizations today have well-defined sustainability strategies. They publish targets, set roadmaps, and report progress across environmental, social, and governance (ESG) dimensions. However, execution happens through people, often in unpredictable, high-risk conditions. According to the International Labor Organization, nearly 3 million workers die globally each year due to occupational accidents and work-related diseases, while 395 million workers sustain non-fatal injuries. From a sustainability perspective, unsafe operations quietly weaken multiple pillars of long-term performance. For example, environmental stewardship is compromised when workplace mishaps escalate into fires, spills, or uncontrolled emissions. Energy efficiency suffers as accidents trigger emergency shutdowns, force energy-intensive restarts, or require temporary operating workarounds. Social responsibility is undermined when worker well-being is treated as expendable rather than foundational to ethical operations. Over time, economic resilience erodes as repeated incidents reduce productivity, disrupt supply chains, and diminish investor and insurer confidence. A clear instance can be seen in industrial fire events, where an initial procedural lapse leads not only to worker injuries, but also to prolonged plant downtime, excess energy consumption during recovery, and environmental remediation costs. Despite their interconnected impact, these consequences are still too often siloed, managed as isolated safety failures rather than recognized as material sustainability risks. The traditional safety systems across high-risk sites rely on periodic inspections by supervisors, training records, and lagging indicators such as total recordable incident rate, TRR, or lost time injuries, LTIs. While useful, they capture the eventual outcomes rather than conditions. AI-based interventions make a shift from retrospective analysis to continuous observation. As per McKinsey, AI has strengthened strategic approaches at work through deeper analysis and insight generation, independent from human bias. The deployment of advanced AI tools like computer vision technology and AI video analytics helps detect unsafe proximity between people and heavy equipment in busy sites. It can proactively identify missing personal protective equipment, PPE, in hazardous zones, or monitor worker fatigue indicators in high-exposure roles. In manufacturing facilities, computer vision systems have substantially reduced hand injury incidents by identifying unsafe interactions with machinery before accidents occur. In construction environments, AI-assisted monitoring has been used to flag fall from height risks, which is the top safety violation listed by OSHA over the years. The significance for sustainability leaders is not the technology itself, but what it reveals: the gap between written policy and lived reality. Environmental incidents around heavy industries rarely originate from environmental intent alone, but begin with breakdowns in human-system interaction, like missed warning signs, procedural drift, or fatigue-driven errors. Investigations by bodies such as the U.S. Chemical Safety and Hazard Investigation Board consistently show that inadequate hazard recognition and lapses in frontline execution are common precursors to fires, explosions, and toxic releases. In the latest report, they mention how accidental release led to 7 fatalities, 23 serious injuries, and around $1 billion in property damage. When workforce risk is reduced, environmental exposure is reduced with it. Fewer human errors translate into fewer unplanned shutdowns that trigger emergency flaring, fewer spills caused by procedural deviation, and fewer instances of equipment misuse that lead to energy loss or emissions spikes. For example, An AI camera located on site can flag a worker smoking within a designated flammable zone by correlating its location data and permit rules. What appears as a minor safety violation is traced to a high probability ignition risk near volatile materials. By intervening early, the system prevents a potential fire, avoiding toxic emissions, asset damage, and an unplanned shutdown, turning human risk detection into a direct environmental safeguard. One of the most significant shifts enabled by AI is the move away from static, retrospective sustainability metrics toward living operational systems that reflect risk as it actually unfolds. AI driven systems introduce a fundamentally different model. By continuously analyzing real time risk signals, behavioral patterns, and environmental conditions, organizations gain visibility into how exposure evolves between inspections and reporting cycles. Predictive insights highlight where risks are trending upward, while verified response timelines reveal how quickly hazards are once identified. This transforms sustainability from a reporting exercise into an active management discipline, where EHS leaders can intervene early rather than react after harm has occurred. Sustainability across heavy industries fails when risk is measured after the fact. When AI models risk as a living system, continuously learning from human behavior, environmental conditions, and operational change, it allows organizations to govern safety and sustainability in real time, not in hindsight. Sustainability is often framed as a future goal, but workforce safety happens now. Every shift, every task, every decision. And AI is revealing that these timelines are not separate. When organizations protect people more effectively, they stabilize operations, conserve resources, reduce emissions, and build trust with the communities they serve. The connection was always there. Technology is simply making it visible. Gary Eng, CEO and co-founder of Viact, comes with a background of building engineering, who turned into AI entrepreneur with inception of Viact in 2016.